Hi, and thanks for tuning in. And this is my explanation of how I approach people when they ask me how I know that the earth is flat. Well, first I'll start off by telling them that in order to understand this, you just need a combination of common sense and imagination. Now, I'll start with this. Water does curve. You heard me, water does curve in the form of droplets. When it rains, you have droplets that form, kind of curved on your windshield and all that. When you pour water from one vessel to another, water does curve. Waterfalls, of course. Even in supposed zero gravity, when you see the astronaut doing the trick where he wrings a towel out and the water conforms all around his hand, yes, water does curve.
But here on Earth, we're not in zero gravity, now are we?
But what I like to specify is that bodies of water don't curve. And that's where a lot of people seem to be confused when I speak with them or when I post on Facebook or in my videos. I'll say bodies of water don't curve, and they will respond by saying, well, what about droplets? I said bodies of water. Now, let me take a moment to define bodies of water. Now, according to Wikipedia, a body of water, or water body, often spelled water body, is any significant accumulation of water, generally on a plane surface. The term most often refers to oceans, seas, and lakes, but includes smaller pools of water such as ponds, wetlands, or more rarely, puddles. A body of water does not have to be still or contained. Rivers, streams, canals, and other geographical features where water moves from one place to another are also considered bodies of water. Again, I say, bodies of water don't curve. And that was the definition there. And the way that I explain this in the simplest form, I'll usually have a glass of water or a bottle of water. And the way that I define a body of water on a small scale is whenever water accumulates to a point that it reaches all edges of its container, such as this bottle of water here. When water accumulates to the point that it reaches all edges of its container, the surface generally lays flat, as you can see behind me. So I'll hold up the bottle of water, and then I'll say, well, you've driven down the road and you've seen a puddle. Now, after it rains, there's a puddle on the side of the road. You drive past it, and the surface of that puddle is generally flat. Or if you go out into your yard after a storm, and you see that water is pooled up in your yard, from one edge to the other, it generally lays flat on the surface. Just the same as a swimming pool, from one edge of the pool to the other, the surface lays generally flat. So I'll continue building up from there. And I'll go on to say, well, if you've ever sat next to a lake on a calm day, as I used to all the time, going fishing with my dad growing up, we would go out bright and early in the morning before the fish started jumping and the wind started blowing and all that. And I remember the surface of the lake from one edge to the other side would always look like a mirror. It would always be just flat like glass. So here's where your common sense plays in. You already know those things. You already know how the surface of water lays generally flat in a cup of water or in a puddle or a pond or on a lake. But here's where your imagination has to take control a little. In order to grasp the idea of the earth being flat, we can simply log on to Google real quick. Open your browser, go to Google, and type in what percentage of the earth is water. And Google will tell you that 71% of the earth's surface is water. So 71% of the earth's surface is water. That's the oceans. So if the rules play the same for this bottle of water to those lakes, the same rules apply to oceans. The surface of the ocean lays generally flat, and any one ocean is connected to all other oceans. It's all one body of water, if you think about it. So 71% of the face of the earth is water. Bodies of water do not curve, therefore the earth is flat. Now, I got into a conversation with a man earlier, and he says, well, but water would have to be contained. I said, yes, well, water would have to be contained in order to lay flat like that. So what's the container? Well, the container is a 360-degree ice wall known as Antarctica. That's what we know as Antarctica, the South Pole. You see, the way that the flat earth works is that the North Pole is at the center, and every direction away from the North Pole is south. Therefore, Antarctica, it's not just a small continent at the bottom of a spinning globe. It's actually a 360-degree ice wall, and that's what holds the waters in. Now, how that ice wall form? Well, here's where we talk about the sun and the moon. The sun and the moon actually make a clockwise circuit around the face of the earth. Now, the sun isn't 93 million miles away, nor is it 400 times the size of the earth. The moon isn't 4 times the size of the earth, and it's not 238,000 miles away. We've been misled about those measurements. Besides, I'd like to know who has the yardstick that actually measured the distance from the earth to the sun. 93 million miles away? I don't know exactly how they came up with that number, and I don't think they do either. But everybody just goes along with it. The fact of the matter is that the sun is small and local. As I said, the sun and the moon, they make a clockwise circuit over the face of the earth. Now, during the summer months here in the northern hemisphere, what we know as the northern hemisphere, the sun will make its circuit closer to the center, to the North Pole. That's why we have a point in Alaska where the sun never sets. Not really. The sun will stay up for basically 24 hours. I heard a guy earlier today saying it was like 22 hours and 15 minutes or so that the sun is constantly in the sky. It'll just dip slowly, slightly below the horizon, and then just come right back up again. This happens every year in Alaska. So during the summertime, the sun's making a tight circuit towards the center. And during the winter months here in what we know as the northern hemisphere, the sun moves faster, but it makes its circuit closer to the outer edge. So when it's cold, it's winter months here in the northern hemisphere. It's actually summertime and spring in the southern hemisphere, below the Tropic of Cancer. That also explains why there's months on end in Alaska where the sun doesn't come up at all. There's months where there is complete darkness. It's always nighttime there, because the light from the sun only lights up about half of the face of the earth at any given time. The sun doesn't reach all the way across this flat plane. It only lights up about half of the earth at any given time. And so that heat from the sun at the same time only reaches about half of the earth. That's why on the flat earth map you'll see in the center, North Pole, you'll see that it's colder there, and on the outer edge you'll see that it's colder out there, because the heat from the sun doesn't reach out that far, and the sun has to move faster around the outer edge. That's why the ice wall accumulates, because that's the coldest place on the face of the earth. You see? So that's the explanation that I give as to the form, the shape, the basic dynamics of the earth being flat. And that's the explanation for bodies of water don't curve. That's the explanation for the ice wall. That's the explanation for the seasons on the flat earth model, in my opinion. That's from what I've gathered. So that's my explanation. I appreciate you tuning in. Be sure to like and subscribe for more content. Be sure to hit the bell so you get the notification whenever these videos are posted. Be sure to link up with myself and the crew over at Flat Life or at the Future of Flat Earth. Be good to each other, take care, and stay flat. I'll see you in the next video.